Good afternoon. Hopefully you can hear me. This is Jeff Flath. Thank you to RNN for inviting us to present. I'd like to talk to you about what eNOW has been doing in the solar industry in regard to transportation. For many of you, you may know this, but the sun produces more energy in 1 hour than the world uses in 1 year. Most of that energy goes wasted. Solar was first discovered in the 7th century and it was used to start fire. The other thing that you may be interested in knowing that solar was first used in space in 1958 on the Vanguard 1 satellite. The Vanguard 1 satellite was actually put into orbit to actually record radiation from the Earth to see how it may affect radio satellites as they were being deployed. Solar is still the primary source of energy for space applications today. So we serve a number of different industries, and what we say is if it moves, we can power it. So we're providing systems for the trucking, RV, marine, and emergency services markets. The challenge is that many of our customers are facing, or the industry is facing in general, are the unpredictable fuel cost that people have seen. You may refer back to 2014, late 2013, early 2014, fuel prices had begun to rise. Fuel prices topped out in some areas at $5 a gallon, and then you've seen those prices drop over the last 18 months to the year back into the $2 per gallon range. But again, there's that unpredictability of not knowing when that's going to happen. The other thing that fleets are faced with are increased maintenance cost, road service cost, battery replacement cost, and always government regulations. So with regard to government regulations, you'll see an increase of emissions controls and so forth, and restrictions on idling and so forth across the industry. The transportation industry has a lot of different worksheets available to fleet owners and so forth to be able to understand what the cost of idling is. And I refer to just the word idling is because as we go through this, you'll notice that what we're talking about is being able to provide a fleet owner or an individual with power so they do not have to idle the engine of the truck to generate electricity to run these various different applications that you'll see here in the next few slides. But you can go online, in addition to going on our website at eNOWenergy.com, you can go on to a variety of other different websites like Argonne National Labs, EPA SmartWay, and so forth, and they provide calculators to help you understand how much money you're wasting in idling. And you can see an example of one of those calculators here in front of you right now. I'm going to sort of show you, this is the calculator that we have developed. Again, you can go to our website at eNOWenergy.com and go to the upper bar and click on calculator. But what this allows you to do, and this is primarily for large commercial fleets and so forth, you can look at this and you can look at your particular application. So you can see I'm running the hand over here. And in that particular box, you can click on that. It's a drop down. And you can look at either liftgate applications, in-cab air conditioning, refrigeration, safety lighting, simple battery charging. And based off of your selection, it will actually input into what the total installed cost is of that system. And then you put in your years of service, how long are you going to keep the equipment, and it sort of walks you through a number of these calculations based off of how you're operating the vehicle, and in addition to that, are you eligible for tax credits, depreciation, and so forth. And as you go through and you input this information and you get to the summary is actually going to show you and give you a pretty good idea of what your return on investment is going to be for that particular, your application. And then from there, we can work with you to understand and gather the data you need on your specific units to determine whether, this is going to be a good value proposition for your fleet. But we actually help commercial trucking, as I explained up front, the RV, boat owners, and so forth, to be able to reduce their total cost by still maintaining driver comfort and as well as accessibility to these auxiliary pieces of equipment to run through their operation without having to idle the engines of these particular trucks. We generate power from our systems. We store power in onboard battery packs, and then we distribute it out to these various different pieces of equipment. And we can actually do this without any large upfront capital expenditure to the fleet. And this is what we refer to as our energy as a service business. And this also helps in reducing the country's carbon footprint and dependence on oil in general. The applications that we are talking about are anything from safety lighting, and when I talk about safety lighting, that could be on an emergency vehicle, as we saw up front. It could be a Department of Transportation vehicle as an application when you're driving down the road and there's road construction and you come up on that road construction, and you may see a vehicle as small as a light-duty pickup truck. And they may have their flashing lights on, and they may have a light bar that's flashing and says that points go one direction or the other, slow down. All of these applications, prior to providing our type of system, were powered by running the engines of the truck. And again, those trucks would sit there anywhere from 6 to 14 hours a day, just running the engine to power those safety lights. And again, that's using fuel, as well as increasing the maintenance cost of that particular vehicle. So again, our systems are applicable to no idle HVAC. If you are in the commercial transportation and you're a Class 7 or a Class So my screen just went dead, and I apologize for that, and we'll still continue, and I'm going to ask Beth to load these slides as we go. So Beth, we're still talking about the no idle HVAC application, where I was describing about the need for in-cab air conditioning to Class 8 drivers. So a Class 8 driver and truck would be something like you would see on the highway, whether it's a Walmart truck, a CVS, a J.B. Hunt. And these are long-distance operators that are basically running the trucks anywhere from 8 to 10 hours per day. And at the end of that period of time, they have to take a rest period. After 11 hours of service, they have to take a rest period for the next 10 hours. And in most of those applications, they are actually idling the engine of the truck. And so what we're doing is we're providing a substitute for that particular truck engine to be able to provide this needed energy for that system. So we generate energy from the solar panel, we store it in a battery pack, and then we can distribute it out for this period of 8 to 12 hours to keep the driver actually comfortable. The same with the liftgate systems as well, where most liftgates are put on trailers, and the only time a liftgate battery gets charged is when that's hooked up to the trailer itself. And so we're able to provide a standalone system to keep those liftgate batteries charged when the trailer is connected to the tractor or when the trailer is separated from the tractor itself. And again, the same with refrigeration, whether that's helping run the refrigeration system, whether it's a mechanical, compressor-operated system, cold plate system. In general, we do the same thing with regard to that particular application. If you can advance the slide to where it says our difference. Currently in the U.S., there's about approximately 125 billion gallons of fuel are used annually in the U.S. for transportation. 10% of that is wasted by idling. So again, this includes anything from a passenger vehicle all the way up through these Class 7, Class 8 trucks, transit buses, school buses, etc. And giving an example, a standard sedan, personal sedan, uses about 0.4 gallons of fuel per hour when idling. And in comparison, a transit bus, so if you're taking public transportation from point A to point B, that transit bus that you pick up at the bus stop and so forth, during idling uses about 0.97 gallons of fuel idling per hour. So again, you can see where a lot of fuel is wasted. 1.25 billion gallons of fuel are wasted alone in the U.S. just because of idling. If you can proceed to the next slide, which is the system slide. And this basically is a rendering of a truck that you can see solar on the top. But again, as we talked about earlier, we generate, we store, and we distribute energy out to these various different pieces of equipment so that people, again, can avoid the high cost of idling. If you advance to the next slide, which is showing a liftgate, again, this is showing with our technology that we can charge from a variety of different sources. So in liftgates, you may see a liftgate on a refrigerated truck, and it may be charging from the reefer alternator that is on that truck. It could be charging from the truck alternator itself, and it can be charged from solar, all simultaneously. And the reason we do this is that we never want to see that truck not have the available power it needs in any case. So whether it's raining, whether it's night, whether it's day, whether it's sunny, whether it's snow, we always have enough energy in that battery pack to provide energy for these auxiliary pieces of equipment when that truck gets to the locations that it needs to deliver whatever goods it has. If you can go to the next slide. People, again, when we're looking at this, we actually have demonstration vehicles on the road, and in these demonstration vehicles, we have monitoring systems that show people how much energy is being produced from solar as we're in that truck, how much energy is coming from the alternator, how much energy is coming from shore power. And so we've created a mobile web-based platform that we install the hardware on the systems that we install in these vehicles, and then the individual driver and the fleet owner can actually see how much energy is being produced and how much energy is being used in real time. And all of these are based off of the amount of energy that we install on the actual fleet and how much energy is being used. And when we can actually send alerts to the individual drivers as well to let them know that they may have an issue with regard to that battery coming up. And so our goal is to provide them with data on state of health of the battery and state of charge of the battery. And that is basically a predictor of how much life you have left in the battery. And so we do not want our customers to be able to go out on the road and get into a situation where they no longer have energy to support the liftgate, for example, or the HVAC. Now again, as I said, I do not have, our internet went down, unfortunately. I'm not looking at the same screen you are, but what I'd like to say is that at any time you can submit any questions that you have through the platform that on Stream Media that you're currently looking at. and we will be able to answer those questions at the end of this particular presentation. But again, I want to encourage you to please submit any of the questions that you may have as we go along here. So if we can move on to the next slide, which is typical paybacks. You can see there with regard to the applications that I'm talking about, liftgate, safety lighting, refrigeration, and so forth. We provide the typical size of the system, and the typical size of the system has been developed based off the experience that we have in the approximate 4,000 systems we have in the marketplace right now in those applications. And so we know pretty much when somebody comes to us and talks about, what do I need for liftgate, we know what size that you would need. But what we're trying to show here is the total installed cost and what the annual savings are based off of fuel savings, maintenance savings, and so forth. So you can see in most of those applications, before any of the tax credits that are available, most of the paybacks are anything from a year and a half or less. When you factor in the federal tax credit, the 30% solar federal tax credit, again, you can get most of those below a year. And then you factor in other things like depreciation. You can see where you can start to get a good return on investment within a period of 6 to 9 months. So give you an example of what I'm talking about when we're talking about generating electricity. A Class 8 truck with a diesel engine at $2.59 per gallon, it costs approximately $1.40 to generate 1 kilowatt of electricity. In comparison, a 300-watt solar system, which is the typical size solar system that we actually install on these Class 8 trucks, will cost around 59 cents per kilowatt hour. And so you can see the big difference between generating electricity through a diesel engine versus generating electricity through these installed solar panels. If you can go to the next page, please, where it talks about commercial transportation. Again, most of the audience may fit into one of these particular categories, but there are currently 1.2 billion vehicles in the world. Again, 1.2 billion vehicles in the world. That's estimated to grow to 2 billion vehicles by the year 2035. So you can see the impact on fuel, the impact on the environment, just by the number of vehicles worldwide that will be on the roads over the next half century or so. So please, if you could go to the next slide. So we talk about what we've developed here, but again, we're not here just to specifically talk about eNOW. We're here to talk about the technology that not only eNOW has developed, but others are developing to be able to take solar energy, which has primarily been used in building applications for residential homes and commercial buildings, and these are glass encapsulated, fairly heavy products. A glass encapsulated panel is about 3/4 of an inch thick, weighs 2.5 to 4 pounds per square foot. In comparison, we've built a very flexible product, which is 1/8 of an inch thick and weighs 0.6 pounds per square foot. So again, it's much more applicable to a mobile environment, and that's why we've introduced that into this marketplace. Gaining traction, we have done a lot of different testing in the marketplace. We have a lot of different documentation that is available to customers and so forth with regard to white papers on no idle applications, test studies that we've done with Ohio State University, for example. In the video that you saw at the beginning, we showed you the testing that Navistar did with the Super Truck program and so forth. So again, any information that you may need from us, you can visit our website at enowenergy.com. And if that information is not readily available, You can also reach out to us and call us and discuss your application, and we can provide the feedback that you're looking for. Again, if you have any questions, please submit them here as we go, and then I'll ask Andrew at the end to read me off the questions so that I'm able to provide you with more information. When we're talking about establishing standards, and again, Beth, if you could move the slide forward, I'd appreciate it, please. So we're talking about the different resources that are available in the marketplace and so forth, and the various different government agencies that we've worked with to try to help establish standards and so forth, whether that be SAE, California Air Research Board, ISO, IEC, et cetera. But again, when we started off in developing this particular technology, we wanted to make sure that as it was adopted in the marketplace, people followed standards. We didn't want to see solar introduced and it be here today and gone tomorrow because people didn't take the time to actually build it into their platform. So again, we tried to set out and establish these procedures so that people had a way and a methodology of deploying it on their platform, on their vehicles. If you go to the next slide, and as we speak, I'm trying to get back into the webinar. Unfortunately, still having the server problem that I talked about. In the slide there, you'll notice that you'll see a locomotive train, and you'll see a truck with solar on the trailer. You'll see a sort of a carport bus stop with solar. The reason for that is the industry itself, the commercial transportation industry, is going to electrification. And what we mean by electrification means that it could be as easy as an all-electric vehicle like the Tesla, the Chevy Bolt, cars like that, where the platform could actually be all electric, or it could be a hybrid. And we feel that the industry is moving towards sort of electric hybrid type of applications where there will be a smaller engine on these particular vehicles, and it will actually be driving a generator that's generating electricity, and that electricity will be used to power all of these different functions. So whether it's the drivetrain and it's driving it's allowing the truck to move down the road, whether it's air conditioning, whether it's brakes, power steering, whatever it may need is going to be powered by electricity versus being converted through a diesel engine and fed that way. So again, we feel that there's a large opportunity here for people to actually look at technology that's available today and will be available tomorrow to help in reducing the idling impact that these vehicles have on the use of fuel as well as greenhouse gas emissions in general. So in closing, we'd like to make sure that people are aware that you can come see us. Again, you can visit us at our website at eNOWenergy.com, or you can actually visit us at two upcoming trade shows, the TMC Expo, which is the Technology and Maintenance Council section of the American Trucking Association. We will actually be in Nashville, Tennessee from February 27th to March 1st. Again, that's the TMC Expo. And then we will be at the NTA Work Truck Show in Indianapolis from March 14th through 16th. So again, if you're out and you attend these events, please stop by and see us, and we can discuss these applications in more details and actually show you the vehicles that we're deploying the technology on. So with that, Andrew, I'll turn that over to you, and if there are questions, maybe you can read those questions to me, and then I can answer them. And again, I apologize that our internet went down And this is something that Beth and I talked about up front, about what would happen, and I'm hoping that people were still able to see the presentation as I was able to go through it.
All right, thanks, Jeff. Yeah, it looks like we were all set and everybody should have been able to see the presentation. Now I saw it on my end, so let's get to a few questions. The first one we have, Jeff, is how can my company get its vehicles outfitted with solar technology?
So we have a number of channel partners throughout the United States, and these are companies like Mitsubishi Fuso Truck, Johnson Truck Body, Anthony Liftgate, Palfinger Liftgate, Dometic Corporation, and our products are available through those entities, and through those companies they have dealers and installers that will actually install our systems on these particular vehicles. We ask customers to start that conversation with us directly so we can help you identify what particular system may be applicable to your particular vehicle and application.
Okay, next question. Is eNOW thinking about doing this on planes and trains and consumer vehicles?
Well, probably not airplanes. And the difficulty, I'm going to talk about the ones that we probably will not be deploying on, are airplanes. And at this point in time, until we're able to increase the efficiency of the panels themselves, there is not enough square feet available on a passenger car to make a difference. Now, that being said, we can do it on a pickup truck. A pickup truck has enough bed space that if you have a hard tonneau cover, you can actually deploy about 250 watts of energy, and that's what we did again with these Department of Transportation, where we were able to provide all of the energy needed to run all of their emergency lighting. Trains, there is a potential. That's not an application that we're currently working on.
Okay, just a couple more. How did you identify and settle on idling as the problem you had to solve?
Well, our team, when we actually founded the company, many of the people on our team have been in the solar industry for years. I mean, we're talking 20, 30 years. Some of our technical team actually came out of the space industry and had worked on satellite, the solar power systems for the rover lander, the space shuttle, the Hubble Space Telescope, the space station, and so forth. So when we decided to start the company, we knew that the cost of converting diesel fuel into electricity had a very good potential payback for our customers, and so we chose to design and develop our product line specifically for these applications versus looking at, again, residential and commercial building applications.
Okay, last question. You touched on this a little bit before, Jeff, when you were talking about the pickup truck application, but maybe there's a little more to this. The question is, can any kind of truck be outfitted with this technology?
Yes. Again, it has to do with the amount of available space and then what the application is. So again, it can be as simple as, a light-duty pickup truck for emergency lighting, or it can be all the way up to the Class 8 tractor trailer that you saw in the video up front on the Navistar Super Truck. That system had 5,400 watts of solar installed on that particular trailer, and it was there to test offloading the alternator, again, diesel-driven alternator generating electricity, and we offloaded the alternator using solar power to improve fuel mileage. So again, it runs a wide gamut of different potential applications.
Okay, well, that will do it for today. I want to say thank you, Jeff, and thank you, everybody, for your participation in today's RNN Masters of Sustainability webinar. On behalf of RNN and eNOW, we hope you enjoyed this presentation, and we hope you join us next time. Our next webinar will be on Wednesday, March 15th, featuring Michael Richardson of eDrive Retro, leading a discussion about restoring classic cars into beautiful electric-powered, sustainable masterpieces. After this webinar is finished, you'll receive an exclusive registration link for our next webinar, and you will also receive, if you want to get some more information about Jeff and about eNOW, you'll receive an updated eNOW product guide. For more information on RNN, you can visit renewablenow.biz. Thanks, everybody.